Okay. Can you see the shared screen, Joshua?
Abo.
Okay, thank you. So, we'll just continue our discussion. Ito, na-cover na natin yung definitions ng acids and bases, different factors that affect acid strength, the equilibrium discussion for dissociation of weak acids and weak bases. So that's what we covered so far. Okay. Also, we looked at the dissociation of polyprotic acids, if you remember. And then from our last meeting, we end up our discussion with the relationship between Ka and Kb of a conjugate acid-base pair, as well as the acid-base properties of salts. Tama? This is where we ended our last meeting, right?
Abo.
Okay. So just remember for this part, you just have to consider the cations and anions that forms our salt. Okay, and then from there you should be able to identify whether the ionized or whether the ions will act as an acid or a base in water. Okay, always remember lang na if it's a conjugate of a strong acid or a strong base, we don't really see any significant acidic or basic properties from those ions. Okay?
Abo.
And also, yung kailangan mo lang ding i-check dito is if it's a conjugate base ba or a conjugate acid. Kasi if it's a conjugate of an acid, then it will act as a base. If it's a conjugate of a base, then it will act as an acid in water, right?
Abo.
So ito yung final topic na last topic natin from our last meeting. Okay? At this point, we will be looking at what we call common ion effect. So for this case, you have to remember the principle or concept we learned from our last meeting, which is the Le Chatelier's principle. Okay? Diba, from the Le Chatelier's principle, we looked at 4 different factors. One is changes in concentration. The other one is changes in pressure or volume. We also looked at the effect of temperature in equilibrium position and also the addition of catalyst. Okay, all those 4 factors, we looked at how equilibrium shifts depending on the stress that was given to the equilibrium system. Okay, so we will extend that idea to what we call common ion effect. Okay. So from the basic idea lang, there will be a shift in equilibrium, okay, caused by addition of a compound having an ion common to the dissolved substance. Okay? Okay.
Mag-ano po
So
siya?
what do you think? So
Abo.
sige.
Ah,
So what do you think will be the effect of these additional ions?
Padagdag po yung isang ion. Well, if that ion is acting more acidic or more basic, then the solution will become more acidic or more basic.
Actually, not really on that part, but remember Le Chatelier's principle. If it's a common ion, you have to look where that ion is. Is it on the product side or on the reactant side? But most likely it will be on the product side kasi ion species na sila eh. Okay? And if it's on the product side, it will actually push your equilibrium to favor more the reactant side. Okay?
Mag-form po siya ulit. Mag-ano po siya, mag-aggregate ulit po.
Yes. Example, if you have ano ba? Common example lang, siguro acetic acid. If you dissolve this in pure water, it will dissociate into hydronium ion, or let's just write it as H plus acetate ion. Okay? But if you mix acetic acid in a mixture of water and sodium acetate. So if you have a container This has in here are sodium ions and acetate ions.
So basically po, if you mix any base or acid with its own salt, then something will shift in the equilibrium.
Okay. So for that case, how will the equilibrium shift? So if you add acetic acid here, it will actually so initially there is already acetate ions present in your mixture. So the presence of acetate ions will actually push the equilibrium to shift from right to left. Okay? If it shifts from right to left, then it will also affect the production of H plus ions. We expect H plus ions to be less compared to the H plus concentration if it is a pure water as a solvent, right?
Abo.
So how do you think will the pH be if it's dissolved in a sodium acetate mixture?
So dun acetic plus neutral, so wala naman siya magagawa. So yung ano po, yung acetic acid will be increased. So
Okay.
eventually it will become, tsaka yung ano po, yung conjugate base na naman, mas mawawala. So it will become more acidic.
More? What more?
More acidic po.
More acidic. Remember our basis for acidity and basicity is pH. Okay, and the only definition of pH or mathematical definition is that it is a
Yes! It
logarithm.
doesn't matter pala po. Ano po to? This is the greatest trick of all time. Just because there's more acid doesn't mean the pH increases. Oh, I was fooled.
Actually, remember that what is originally present in the mixture are acetate ions. Acetate actually is basic in its form. Kasi acetate form siya. So basic yung characteristic nito. Acetic acid with the H is acidic, while acetate is basic, right?
Abo.
Okay. And also, if you look at the Le Chatelier's principle, itutulak niya yung equilibrium pabalik. So we expect less of H plus to be produced. So dahil ang basis lang talaga ng acidity or basicity is the pH. Okay? So we expect between solution of acetic acid, so if you have here acetic acid in pure water, oops. And let's say that the amount of acetic acid we put on both the solutions are the same amount. So we expect the pH here to be lower. Okay? The pH of acetic acid in pure water would be lower compared to the pH of acetic acid dissolved in water with sodium and acetate ions.
So this is
Okay?
so ito po yung acid and or base will react with the salt na it's not acidic or basic yung hindi po siya opposite. And then
Actually,
it
hindi
will
na siya
still be
mag-react.
decreased.
Hindi siya
Ito na
talaga reduction. It's more of the presence of the acetate ion will push the equilibrium, okay, to shift from right to left. Okay,
it doesn't,
the
so it
Chatelier's
doesn't,
principle. Is that clear?
abo. So
Okay.
it doesn't necessarily need the base po to counteract an acid or at least increase its pH.
Pwede din naman, actually, pwedeng ganun mo siya tignan, pero yung best, I think the best explanation here is by using the Le Chatelier's principle. Okay? Pero what you mentioned is also makes sense. Kasi if there's already an acetate ion, then it will actually abstract the protons na available. Tama?
Abo.
Okay. Pwede rin naman yon. But whichever explanation you look at, it will always lead to the same result, which actually which is on the increase of pH of the solution, right?
Abo.
Okay. Clear? Is this clear?
Opo.
And also remember, sodium ion here is just a spectator ion. Okay? So, siguro in a simple sense, wag mo lang pansinin yung sodium ions. It will not affect the pH of the solution. Okay? Although actually, in advanced classes, meron din talagang effect yung mga spectator ions. Okay?
So,
Pero very
opo, parang kumbaga yung spectator ayos nagkatapon ng hotdog sa arena. Tapos may, hindi po natama tuloy kasi natinangan yung hotdog.
pero ano lang, tawag dito, yung effect nila actually is very minimal na pwede naman natin silang i-disregard at least for this common setup. Kasi yung effect nila sobrang maliit lang naman. Okay?
Opo.
Okay. Now let's look at this problem. So what is the pH of a solution made by adding 0.62 moles of acetic acid and 0.57 mole of sodium acetate, okay, to make 2.0 liter solution. Okay. For this, let me solve the problem. Or actually, hindi naman. I-solve natin siya ng sabay. Okay? Pero let me do the rate.
When ano po, news po, you will have to solve the problem.
Not yet pa naman. Pero actually, madali lang to. The same way we did for other equilibrium problems, ganun pa din naman yung gagawin natin dito. First, write down the equilibrium reaction. For this case, I think the best equilibrium reaction that we have to write is the dissociation of acetic acid. Okay? So let's write down acetic acid as HAC na lang. Okay, just to simplify stuff.
Simplify po, it's a code name for laziness. Chemists when they forget how to write the acetate ion.
Well, sana naman hindi mag-lead sa ganun. Pero we still know the chemical formula for acetic acid naman. Okay? Which is our code name for laziness. Let's write it down as HAC na lang. Okay? And then we construct our ice table. Actually, for this case, whether you write the dissociation reaction of acetic acid or the dissociation of acetate as a base, you should obtain the same answer. Okay? Pero ang simplest way dito is to write down the dissociation of acetic acid. Okay?
Why will it simplify it? Why will it simplify it by doing the acid?
First off, the available value for Kas are for the acetic acid and not for sodium acetate.
Okay.
Right?
So, kaya pala. I realize po, parang binabias na naman ng mga base.
And also, if you do the base dissociation of sodium acetate, what you will get are hydroxide ions. So you need to take the negative logarithm, you get POH, from POH you can get pH. Right?
May extra step
marami pang mga additional steps.
Abo.
So for the acetic acid concentration, what is it initially?
H is 0.62 moles 2 liters. I don't know pala. 0.31 moles. Molar.
So it's 0.31 molar. Okay? Molar. H plus, what is the initial concentration?
Yun din po, the same thing. 0.31 kasi acetic acid.
Initial
may weak acid pala po siya, hindi siya full dissociation. 962 moles acetic acid. 0. Hindi, kasi hindi na-confuse ako, wala pa pala pong na-produce na H plus in the very beginning.
Yes. Nasa initial stage pa lang, okay? Wala pang munang dissociation. You just simply add up the reagents. first. Okay? Acetate ion.
0 rin po.
For this case, there is
Oh, no, there's
already a
sodium acetate. There's
significant
sodium acetate.
amount of acetate.
No!
Okay?
I was fooled again. Kaya pala pa inisip ko po, ba't kaya tinatanong din po to? Parang meron sigurong trick.
Okay. For this case, tawag dito, mixture na siya. Okay? May mixture ka na ng significant amount ng acetic acid and acetate ions. For this case, it is sodium acetate. So yung sodium acetate is our source of acetate ion. And remember, sodium ion is just considered as a spectator ion. Now, what is the initial concentration for the acetate ion?
How do we assume po if does the sodium acetate fully dissociate?
Yeah, di ba, sodium acetate is a soluble salt. All
Completely soluble.
all sodium salts are completely soluble, right? Solubility rule. Remember from solubility rule.
Kala ko po baka may assumption pa all are dissolved. So 0.57.
For this case, always remember the solubility rule. Okay? Pero most likely for this kind of problem, you will not be given a type of salt na hindi naman pala madidissolve. Kasi kapag hindi siya na-dissolve, it will have a different effect on the equilibrium.
As lalagay niyo po sa barium sulfate tapos hindi pala barium sulfate. So disodium sulfate lalagay niyo po doon sa hindi naman nagdi-dissolve.
Sodium sulfate is soluble,
Wait, ano kasi yung non-soluble sulfate? Ammonium sulfate! Ayun, ammonium sulfate. Barium sulfate pala, tama po ako. Ay, baliktad po. Kala ko po all sulfates are soluble except for barium sulfate. Yun pala, all sulfates are soluble except for barium sulfate.
So for acetate ion here on this problem, what is the initial concentration?
0.285 molar.
0.285 molar. Okay? For the change, this is minus x plus x plus x. Okay? Ganun pa rin naman. Now, at equilibrium, we expect the concentrations to be equal to 0.31 minus x. This is x. And this is 0.285 plus x. Okay?
Opo.
From this ice table, we can write down our Ka expression as x times 0.285 plus x all over 0.31 minus x. This is equal to?
Whatever the... No, this must be remembered. 1.8 times... Kaya pala po, parang walang binigay. 1.8 times 10 to the negative 5.
Okay, that's good. So it's 1.8 times 10 to the negative 5.
Finally.
Okay. Now, at this point, what do we do?
Nothing. Quadratic
Nothing.
Quadratic equation. It is impossible.
So for this, what is the value of x?
The shift button after seeing so much battle already. Mm. 1.9576 times 10 to the negative 5.
95764 or 5? Or dito na lang, 9576 times 10 raised to negative 5. Okay? This x here represents the concentration of H plus, right? So with this value of x, the pH of the solution is equal to?
Negative log x. equals 4.708. Bro, it's not even,
4.708.
mas acidic pa po yung cola kaysa dito sa solution.
Yes. Okay. Now, eto, one quick solving lang. For this 2-liter solution, what will be the pH if you add just 0.62 mole of acetic acid? Okay? If yun lang, you don't add any sodium acetate, just 0.62 mole of acetic acid dissolve in a solution to dissolve in water to make a 2-liter solution. What will be the pH of
Then it,
solution?
then it would be easier po because the acetate would have 0 in the beginning. Negative log. 2.62 po.
Okay,
Mas
it's
laki na distance
2.628, right?
Almost 100
For
times? More than 100 times po?
0.62 mole acetic acid in 2-liter solution. Okay, pH is equal to 2.628. Okay, now imagine the difference in pH, right? Now,
Ginakalculate ko nga
because
po
you
eh.
add sodium acetate, it will actually push your equilibrium back. Okay? Mas i-favor niya yung reactant side. That's why less H plus will be produced and so pH will be higher. Right?
Opo.
Okay. Also, yung kagaya ng sinabi mo kanina, you may think of it as acetate ion reacting with the H plus. Right?
Opo.
Which is actually the same thing ng sinasabi ng Le Chatelier's principle. Okay? Additional common ion or additional common species will react to form yung side nung kung saan mang side ng reaction yun. Okay?
But in fairness naman po, medyo malaki naman po ang 0.57 moles of sodium acetate. Halos 40 grams
Yeah,
po eh.
that's true. Okay. Pero for this case, what we looked at is the effect of the common ions. Okay? Is this clear? Questions? Do you have questions?
Wala po.
Okay.
Question po.
Now,
May question po ako. Will I solve the next problem?
ano yun? Ano yung question?
Will I solve the next problem po?
We will see. Titignan pa natin kung ano yung ano. Okay. Pero let's proceed muna with our discussion. Okay? Now, you have already seen the common ion effect. There is also what we call buffered solutions. Familiar with the term?
Yung titration po yung nilalagyan ng konting acid or base para hindi basta po nag-change yung pH.
Okay. Actually, yung buffer yung ina-add. Usually, if you have an aqueous solution, if you don't want the pH to adjust drastically, you have to add buffer in your solution. Okay? So buffered solutions or simply buffers are solutions of weak acids or bases and its salt. The solutions resist significant changes in pH upon addition of small amounts of strong acids or strong bases. Okay, so first, what you need to remember is that buffers are made out of acids of a conjugate of an acid and its conjugate base, or a weak base and its conjugate acid. Okay, it has to be a conjugate acid-base pair. Okay.
Kung in the world
Now,
po, had enough time to study, what if I mix the conjugate base and acid and then put it into this solution?
ano yun? Sorry, hindi ko nasaan.
How was it possible, how was it discovered na bigla na lang someone placed the acid and base conjugate pair and then found out Hey, the pH doesn't change that drastically. What if I use it?
Well, actually, I'm not sure about the discovery, but we have an explanation to the behavior. Okay, so maybe pag nakita mo kung paano siya gumagana, then you'll have a more understanding kung paano kaya possibly nakita. I'm not sure kung yung concept ba yung nauna or yung discovery ng properties ng solution. I don't know. I'm not really sure. Okay, but
Abo.
let's look at how buffers work. Okay, look at this illustration here. So in the middle, this is a solution of acetic acid and its conjugate base, acetate ion. And for this solution, there are equal amounts of acetic acid and acetate ions. Okay, so this is considered a buffered solution or a buffer. Okay, now if you add a strong base, okay, in the form of hydroxide ion, say sodium hydroxide or potassium hydroxide, okay, this hydroxide ion will react with the weak acid. Okay, so if it reacts, it will abstract some proton from acetic acid, forming acetate ion. Okay, and OH minus becomes just water, right?
Wait a minute. This is genius. This is a genius mechanism. Gagawin po niya, it will turn it into the conjugate base, but then there's a common ion effect. So it will just go back and go back and forth. No,
So
this is
that's for the
this is mind blowing.
ang galing, di ba? Now, aside from the base, if you'll notice, ganun din, if you add a strong acid in the form of H3O+, this will act or this will react with the conjugate base forming acetic acid. Okay? So, as a result, you won't really observe any increase in either OH minus or H plus concentration. Right? Because whenever you add OH minus or H plus directly, it can react with either the weak acid or the conjugate base. Okay, okay. Okay. So that's how buffers work. That's the reason why it can actually resist drastic changes in pH. Okay?
Abo.
Okay. Now, there's this equation we call the Henderson-Hasselbalch equation, given by this equation here. If you'll notice, this is actually just based on the Ka expression, which is
Negative
H
log
plus, yes,
Ah! I see how it came.
times,
So yung ano po, yung PKA po negative log KA. So
so if
magkaka-division po.
magkaka,
Magkaka-division po sa logarithms.
deviation sa final pH,
Division po pala. Division po. So magiging
division.
log an ion over HA tapos minus log KA. The
Actually, yes.
KA will go on the bottom.
If we start with the Ka expression, but this is our Ka expression, if you take the negative logarithm of both sides, we get pKa here. And then ito, may multiplication, pwede natin siyang paghiwalayin into negative log of H plus negative log of A minus over HA. And this term here is just equivalent to pH, right? This one. This is equal to pKa minus logarithm of A minus over HA. Now, by rearranging, we will arrive with this equation here. Tama? Lipat lang natin to sa kabilang side ng equation. Clear? Is this clear?
Abo.
Okay. Now, this equation here is what we call the Henderson-Hasselbalch equation. Just be careful kasi it only works for buffers.
Huh?
Okay? This equation here only works for buffers. Why? Kasi what we do actually is we do direct substitution. whatever initial concentration we have for the conjugate base and the weak acid, direct substitution na lang siya. Okay? So, we do an assumption na, di ba, ito dapat ay initial concentration ni A minus plus X. And this is initial concentration of HA minus X. Tama? Yung term dito.
Opo.
Okay? So we just neglect the additional X or the minus X. So we just simply put the initial concentrations here. Okay? Kasi if you'll notice for buffers, wala masyadong effect. So hindi masyadong significant yung plus X at yung minus X. Right?
Opo.
Okay. But that's only for a buffer solution in which there is a significant amount of both the weak acid and its conjugate base. Kasi kapag hindi significant yung amount nila, then baka hindi mag-work yung hindi mag-work yung assumption na tanggalin si plus X pati si minus X. Right? Okay. So ano lang, be careful lang. For this equation, it only works for buffers. Pero kung gusto mo pa rin ng mas mahabang calculation, you can still do the ice table. That would also give you the same answer. Dapat. Okay?
Ano po yun, pang sa mga sa mga marami pong oras yun.
para doon sa mga yon. Pero kapag kunyari sobrang limited lang yung time na binigay but you have to calculate for pH, then it means na you are expected to actually use the Henderson-Hasselbalch equation. Okay?
Opo.
Actually, may isa pang form si Henderson-Hasselbalch eh. POH, this is equal to PK.
POH is obsolete.
Plus logarithm of BH plus over base. Galing naman to sa base dissociation. Pero kahit alin dyan, okay lang. Just make sure, actually, kahit wag mo na itong tandaan, kahit ito lang. Even if it's a base, okay, even if it's a base dissociation, pwede mo na itong gamitin. But remember, this is pKa. So what you need to get for the negative logarithm is the Ka of the conjugate acid. So kunyari, you are given an ammonia-ammonium buffered solution. Ammonia-ammonium buffered solution. So ang gagamitin mong pKa dito ay pKa ni ammonium. Okay, and this is ammonia, initial concentration. This is ammonium, initial concentration.
Opo.
Does that make sense?
Opo.
Okay. Yeah, kasi normally kapag ammonia-ammonium, ang ibibigay dyan ay Kb. Or ang makukuha mo sa table ay Kbs, right?
Opo. Are there certain buffers that parang they lean more on the acidic side pero kesa sa basic side po do they kung
Yes,
ganun po
may mga ganon. And
do they label it? Do they label it po kung acidic leaning or basic leaning?
Actually, instead of just labeling, usually we just write down the components. And from the components, you should be able to tell whether the buffer is acidic or basic. Okay? Titignan natin yon after we look at this practice exercise. Okay? Pero sige na nga. Before we do this practice exercise, sige, I'll expound more onto that na lang. Now, this is the Henderson-Hasselbalch equation. pH is equal to pKa plus logarithm of A minus over HA. Okay? Now, imagine you have a buffer in which the concentration of the weak acid and its conjugate base are equal. Okay? If it's equal, the ratio here would just be equal to 1, right? Logarithm of 1 is
0.
So for that mixture, if you have a buffered solution in which the concentration of the weak acid and its conjugate base are equal, pH will just be equal to the pKa of the acid.
That's epic.
Okay?
Okay.
Okay. Now, for a system, for a buffered system in which A minus is 10 times greater than the HA concentration. Okay? If A minus is 10 times greater than the HA concentration, then we get a logarithm of 10. Okay? So logarithm of 10 is
1.
1.
Oh, this is the plus
Okay?
minus 1 equation.
Okay. For a buffered solution in which the weak acid is 10 times greater than the concentration of its its conjugate base, then we have to get the logarithm of 1 over 10, which is equal to -1, right?
Abo.
So there is a relationship given by this equation. pH is equal to pKa plus minus 1. This is what we call the buffering capacity. Okay? Meaning if you want Meaning if you want your buffer to work properly, it has to be within this limit. Okay? Kasi if the concentration of the weak acid is very, very low, for example, then most likely it will not act the way it should. So kapag sobrang baba ng acetate ion, baka pag naglagay ka ng strong acid, baka halos maubos niya yung weak base and mag-shoot up yung pH.
So yung
Okay?
best po yung parang ito po yung acceptable range. Kung pwedeng so sabihin po kung if ideally pH must be equal to pKa para maging perfect buffer.
Yes. So yung idea nito is, if for example, you want to maintain the pH at around neutral pH. Di ba neutral pH is pH equals 7.0?
Abo.
If you are working with a solution which pH is neutral and you want to keep it as at that level, okay, you have to have a mixture or a buffered mixture na yung pKa ay nasa plus minus 1 nito. Na yung pKa plus minus 1 ay pasok ito. Okay? Okay. So kunyari, acetic acid buffer. Okay? For acetic acid buffer, pKa of acetic acid is
whatever that negative log 1.8 times negative 4. 4.744.
4.75. Tama ba?
Abo, 4.744.
Okay. Or around this value. Okay. Now, for an acetic acid buffered solution, it only works kung ang gusto mong i-maintain na pH ay around 4.75. Okay? So, kunyari, gusto mong i-maintain yung pH at around to pH 8. Kung around pH 8, hindi mo dapat gamitin si acetic acid buffer.
So, dapat,
Okay?
so I see po kaya po nalalagay na po yun, no? Yun, in order to, hindi pala pwede siyang, parang universal buffer. It needs,
Hindi, walang ganun.
It needs yung mismo, na po yung parang, yung ginagamit niya pong ions must be, tsaka yung ions, tsaka yung mismong acid or base. It needs to be yung, yun po yung maintain niyo po.
Yes. So, dapat ganun siya. Okay? Usually kapag 7.0, commonly we use PBS. PBS is phosphate buffers solution. Okay? Usually phosphate buffer solution has a pH of 7. Kasi nasa around 7.2 yata yung pKa nito. Okay?
Abo.
Tapos naman usually kapag mga high pH na solution, I'm not sure kung ano yung exact value. Around 10 point something yata. You can use ammonium buffer. Okay?
Abo.
Okay. Anong pH dapat kapag ammonium buffer? pH plus
Whatever,
minus, what pH plus minus 1 yung range?
whatever 110 or 40 minus 4.75 approximately is. Mga 9.25.
Okay, around 9.25 plus minus 1. So within this range, if you want to maintain the pH of your solution within this range, you can use ammonia-ammonium buffered system. Okay?
Abo.
Is that clear?
Abo.
Okay. Now, let's proceed with these questions here. Okay? Which of the following solutions can be classified as a buffer system? A.
Uh,
This
mm,
is potassium dihydrogen phosphate and phosphoric acid mixture. Can you make a buffered solution out of these reagents?
Actually, this is a tricky question po kasi hindi po yata na yung ano po doon yung mga polyprotic. I have no idea actually if it will technically work as a buffer system because it will continue to dissociate even though so technically po the dihydrogen phosphate ion is not very stable in a sense. It will just keep on dissociating them.
For that,
So
remember, di ba actually for that, if we look at the dissociation of phosphoric acid, H3PO4, it will form H plus and dihydrogen phosphate. Okay? And then dihydrogen phosphate, it will dissociate to form additional H plus and hydrogen phosphate. And meron pa siyang third equilibrium reaction, right? Ito yung dissociation naman ito to form phosphate. Okay?
abo.
So to answer this, actually just look at the pair if it's a conjugate acid-base pair. For this case, the conjugate base of phosphoric acid is dihydrogen phosphate. So you can
Oh,
still make a buffer.
kala
Okay?
ko po, it's supposed to be phosphate. Pwede pa naman lang.
No,
Pwede pa lang.
phosphate is the conjugate base of hydrogen phosphate. Diba?
Well, is the,
Hydrogen
so,
phosphate.
so yung
This is
H2PO4 po is basic. And then the conjugate, the bisulfite po will become acidic. In turn, making the phosphate basic po.
no, actually, you can't look at it as either just basic or acidic. Remember, yung mga nasa pagitan, they are amphiprotic. Okay?
Antiprotic pala. Okay.
Amphiprotic yan eh. Kasi it can donate proton, it can also accept proton. Right? So, it's wrong na tignan mo lang siya on just one direction. Okay? Kasi they can act either way, depending on the other species present in the mixture. Okay? Now, also remember that in a buffered solution, both the acid and its conjugate base, or the base and its conjugate acid, should be present in significant amounts. Okay? Kaya kung ang worry mo is meron pang mga second and third dissociation reaction, that will not predominate kasi yung significant amount na species ay itong dalawa. So most likely, ang magdo-dominate na equilibrium reaction is the first equilibrium reaction. Okay?
Abo.
Okay. Tsaka ito, meron kang significant amount ng phosphoric acid, meron ka ding significant amount ng biphosphate. So most likely, dito lang yan iikot. Okay? Less na yung magiging contribution. Although it still happens, definitely, the second dissociation and the third dissociation will still definitely happen doon sa mixture natin. But their contribution to the equilibrium position will not be that significant. Okay?
Abo.
Kasi yung significant na present doon sa mixture natin ay itong dalawang species na to. Is that clear? So the answer for letter A is yes. Okay? We can make a buffered system out of this mixture. Okay?
Meron ba po
Actually, yung
talagang, meron ba po talagang totoong buffer system na ganito po ginagamit?
yes, yung PBS.
Bro!
PBS is complete buffered solution. Okay? Although yung pH 7, ano to, this is a mixture of, PBS kasi tatlong system yan eh. Pwede kang mixture ng phosphoric acid and dihydrogen phosphate. So tatlong buffers yung pwede mong gawin actually. Pwedeng mixture nito, ito yung isa. Yung pangalawa, pwedeng mixture ng, ito yung may pH 7, mixture ng hydrogen phosphate and dihydrogen phosphate and hydrogen phosphate. Ito yung may pH 7.
Kasi
So you can
it's falling into the amphiprotic range na po. It's falling into the amphiprotic na ano na po. Properties na po.
Yes, pero dahil buffer sila at itong dalawa yung significant yung concentration, itong dalawang mixture na to. So most likely ang nagdo-dominate na equilibrium reaction is yung second reaction. Okay?
Opo.
And yung pKa ng second reaction is around 7. I think 7.2. So yung PBS buffer na may pH 7, itong buffer system 'yon. Okay?
Opo.
Pwede ka rin gumawa ng buffer system out of hydrogen phosphate and phosphate. Mas mataas yung pH niyan. I think around 8 or 9. I'm not really sure, pero mga around that value. Okay?
Opo.
Okay. So dito pa lang actually, sa phosphate buffer pa lang, pwede ka nang gumawa ng tatlong buffers na iba-iba ang pH.
Opo. Meron ba pong mga scientists that like invent acids to just to use parang ito pong range na to para sa ito pong buffer?
Actually, ano naman, kahit sa mga common lang na mga reagents na meron tayo, parang halos lahat ng pH range kaya nang i-cover eh.
Opo.
From common buffers lang. Actually, yung mga common buffers lang naman is buffer 4, buffer 7, and buffer 10. Yun yung mga common na buffer system.
Opo.
Pero kung gusto mo talagang sobrang specific at sobrang pasok talaga dun sa buffering capacity, then you may look for some other buffers. And hindi siya ganun kahirap. Minsan kahit common acids or weak bases lang, pwede kang makakuha pwede kang makapili ng desired pH range mo.
Napagagawin na po sa paano pa nun sa mga NSA po na go, NSA tuloy. Yung NIST po, NIST na ano po, yung i-search na po yung PKA, tapos ang hahanap po kayo na tama-tama.
Pwede, ganyan. Pero also you have to consider the availability of the reagent. Kasi baka mamaya, gusto ko to, kaso nga lang hindi pala pwede or hindi pala nabibili yun dito sa Pilipinas, kunyari. Pero kahit mga common reagents, halos kaya natin i-cover yung malaking pH range.
Abo.
Okay? Letter B.
Obviously, kaya po.
Sure?
This is the HClO3 naman will chlorate ion naman po yung conjugate. Tapos ang sodium naman wala gagawin. Abo, yes. This can form a buffer solution, I think.
Okay. For letter B, it's a no.
What?
Why not? Why do you think?
This went from an easy problem to a very hard problem.
May nakalimutan ka. Remember, buffers are made out of a weak acid and its conjugate base or a weak base and its conjugate acid.
Oh, it can't be a strong acid. Bro, this is just painful.
Kasi kapag strong acid siya, kunyari, you have sodium chlorate and perchloric acid. If you add H+, hindi magre-react si H+ kay perchlorate. Tama? Kasi ayaw na mag-form ng perchlorate tuloy, kay chlorate. So if you add a strong acid, hindi magre-react yun kay chlorate. Kasi ayaw niya mag-form ng chloric acid because chloric acid is a strong acid.
It tends to dissociate, not associate.
Yes. 100% ang dissociation ng strong acids, remember? So there's no way for chlorate ion to associate with the H+.
I'm completely doomed. I saw no problem.
Pero hindi ko kasi siya binanggit kanina. Okay? Ano ko lang, nilagay ko talaga siya for letter B para okay, sige, para hindi muna niya mapansin. Kasi syempre dun muna tayo sa answer na medyo obvious na yes. Kasi ano to phosphoric acid mixture. For letter B, take note that the given is a strong acid. That's the reason why you can't make a buffered solution out of this. Okay?
Abo.
Is this clear?
Maybe. This is methylamine and then methylamyl chloride. Methylamine, I have no idea if this is strong.
Methylammonium. Actually, you read this, I think, as methylammonium chloride. Kasi protonated na siya yung nitrogen. So, it's a methylammonium chloride. Okay? So, what's your answer for letter C?
It's a weak base and I don't know if this is a... Is this a strong acid? Is this even an acid? Okay, this is probably not an acid. This is just salt. Okay. I'm having... Oh! Dang! An emergency meeting. The error has been spotted. There's an NH3. It's not NH2Cl. No.
Your answer is?
No po.
Bakit siya NH3 sa tingin mo?
Parang bigla lang, di ba po dapat yung conjugate na po? But it's not just CH3NH3 plus, but CH3NH3 plus tapos may Cl minus, making it
just what is Cl here? Ano to?
Cl is just a spectator ion.
Yes, chloride here is just a spectator ion. Okay.
Wait, but CH3NH3 is just simply the positive conjugate acid. My judgment is so wrong. It turns out pala na essentially removing all the spectator ions. The CH3NH3 is simply just the CH3NH3 is simply just the conjugate acid of the methylammonium.
So ano siya ngayon? Can you make a buffered system? Yes or no for letter C?
Judgment time times 100. Abo.
Yes,
Maybe.
final answer.
Final cube.
Ano yan? Final answer? Yes.
Final squared po. Final squared. Ito na po talaga yung pinaka-final answer.
Okay, for this, it is a yes. Okay, you can make a buffered solution. Kasi 'di ba CH3NH3, huwag kang magpalito dun sa sa kung paano siya sinulat. Chloride here is just a spectator ion and CH3NH3 plus is actually just the conjugate acid. Okay? Kasi 'di ba, this is a base. When you dissolve it in water, it will abstract proton from water. So pag kumuha siya ng proton, malalagyan ng extra HCN and it will become positively charged. Right?
Abo.
Okay. So this CH3NH3 plus is the conjugate acid. So it is a conjugate acid-base pair. Okay?
Abo.
So answer for C is yes. Okay? This can be a buffered system. Letter D.
Letter D. This is either a trick question or an extremely well-structured question. NaOH. Na is a spectator ion, therefore OH the essential ion. The conjugate is H2O. H2O is assumed to be present in the NaCl as there is only Na plus and then Cl minus. But but is the NaCl assumed to be aqueous or not? I have no idea. But if I assume this to be at aqueous, then ano po, basically the only present ion, the only present essential ions or acids bases are OH minus and H2O. So therefore, it is possible. Wait, it is possible. Any OH is a strong base. Not impossible.
So, final answer.
It seems plausible at first until I see strong base. Final answer na po, no.
Okay, correct. Okay,
Finally,
kinabahan ako
finally.
dun sa kinabahan ako dun sa unang mga explanation. Sabi ko, is looking at water as water OH minus as the conjugate acid base pair. Well, for that case, we have here the hydroxide ion. So strong base is sodium hydroxide. We can't make this a buffered solution. Okay?
Opo, I realized I was thinking about if it was correct, but then I realized there's another condition if it's possible.
Actually, naantay ko lang kailangan niya mapansin. Kanya mapansin. Sodium hydroxide is a strong base. Sodium hydroxide is a strong base. Okay? Pero good thing you noticed. Okay? Sodium hydroxide is a strong base. Therefore, you can't make this a buffered solution. Okay?
HF is a weak acid, therefore it is immediately possible, but not really very possible. HF is the essential ion is F. HF. That's it. There's no ion. It's just HF pala. And then KF is essential ion is technically just F minus. And that is an acid base. That's an acid conjugate base pair. And HF is a weak acid anyway. K is just a spectator ion hopefully. So yes po. This can be a buffer system.
Final answer?
Is there a mistake? There must be a mistake. F minus. Nothing naman is wrong. Opo. Final answer, I think.
Yan, nag-doubt ka kagad. It's correct. Okay? This can be a buffered solution. Huwag ka mag-doubt.
Because
Pero tama.
that's the yan po yung downfall ko po eh. When sinabi po, huwag ka po na mag-doubt. Tapos nakita ko po, sige, parang mo, tama naman. Tapos kumaga po may missing na decimal point ako nagalaw. Siguro na yan. Siguro typo lang po yun. Totoo na pala yun. It was really part of the question.
Pero actually, the moment you see letter E, yung umpisa ng analysis mo sa system, that's correct. Okay, it's entirely correct and you got it correct for the final answer. Okay?
Correct
So you
square.
can see so this is a buffered system. Okay? HF and PF minus. K plus is just a spectator ion. And the fluoride is the conjugate base of HF or hydrofluoric acid. Is this clear?
Abo.
Questions? Do you have questions?
Wala po.
Actually, dito pala, medyo nahuli yung slide on buffering capacity. Pero we already discussed that. Okay. Now, for this, let's try to, we already did this one. Okay, actually umulit lang siya. Okay. But if you'll notice, the problem I gave here for the common ion effect is actually just a buffered mixture. Okay. If you notice, it's actually just a buffered mixture. So you have a significant amount of acetic acid and its conjugate base, sodium acetate, in this solution. So this solution here is a buffered mixture. Okay. Now, let's look at this problem. Wag na tong 20. Ito na lang. Let's try to answer question number 21. Okay? This time, ikaw gagawa nung ano.
I will do it completely. And then for some reason po, I was left without any space. Almost the copy paste if something.
So for this problem, calculate the pH of a 0.30 molar ammonia and 0.36 ammonium chloride buffer system.
Graphic tablet na yun. Ito po yung the very use. I forgot the molar mass of nitrogen. 16. Oh no, I'm useless without it. 14.0 po yung ano? Yung nitrogen?
Number of moles, atomic mass.
Opo.
The concentrations are already given. They're already expressed in molarity.
I don't need the molar mass. Why did I need to think about the molar mass? Ice table. Wait, what am I doing?
Whether you use the ice table or the Henderson-Hasselbalch equation, it's fine. Kahit alin doon, you should arrive with the same answer.
I could, but then I prefer to use the Cybertruck po instead of the Model T. Okay, pH equals what's the
Pero
pH?
clear yung problem. Okay, clear yung problem.
Abo.
Joshua, while you're answering, bababa lang ako saglit. I'll get some water. Very quick lang.
Bro. Ano po, I ran into an existential. Is it,
What happened? What?
like, ano po, I'm starting to have doubts eh. Really, is it really, ano po, is it really, okay, I think I'm on the right track, but then something is wrong. Because apparently it is too acidic to be, it is too acidic. I got 0.665, which cannot be
Okay.
possible.
I think maybe before you proceed with the equations, write down first the reaction involved.
I can. Uh, for CL naman is neutral. Archaic pa yung pagkasulat.
What else? Something's missing. Okay. Now, for that reaction, what you are producing is
Ammonium
H
ion.
minus, right? And this equation here has an equivalent, oh, sorry, KB and not KA. Tama.
Ginagamit po pala KB pag ano po yung baliktad po na yung ano po ay Henderson-Hasselbalch equation.
Remember this equation here, this came from the KA expression. Tama. And for this expression, pH is equal to pKa. What is 1.8 times 10 raised to -5? Diba that's Kb of ammonia, right?
No, literally destroyed. So
Diba? So negative
I
log of
will get
this is
that
not
one.
pKa.
And then this will be flipped. Yeah, Alice. Ayun. Huh? Iwan ba? Ayun. Kapulong kasi ginagamit po KA pa rin po pag basic. Kasi yun nakasulat po sa nakasulat po sa ano. Siguro nagka-type po. It's just going on.
Okay, so final answer is
Mga 9.2 po.
okay, or around 9.18, right?
Abo.
Okay. So be careful. Kaya ito yung pinili ko kasi this is a basic buffer. Okay.
It's a very evil problem.
Then ano lang, yun naman sa binigay ko to just so you will be familiar with how to approach depending on what buffer system you have. Okay? Pero for this case, actually, you can also use pH equals pKa plus log of base over acid. Okay? Pero this time, what you need to use is the pKa of the acid, which is ammonium. Tama? What is pKa of ammonium?
pKa of ammonium is, I don't know.
It is equal to negative log of 10 to negative 14 over 1.8 times 10 raised to negative 5.
KW, pag conjugate mo, KW is equal to KW is equal to KB times Ka.
Yes. So you can just write it as this. Plus log of A minus is 0.3 over 0.36. Pwede rin ganito lang. Tama. So if you solve 10 to negative 14 over 1.8 times 10 raised to negative 5 plus log of 0.3 over 0.36. So it's the same, 9.18. Clear? Okay. Pareho lang siya. Kapag POH, actually tanda mo lang, kapag pH form ng Henderson, pKa tapos base over acid. Kapag POH form, pKb plus log of acid over base. Okay, okay?
Apo.
Question, do you have question?
Wala naman po.
Clear, this is clear.
Apo.
Okay. Pwede na erase yung annotations?
Sino na po dyan?
Yes, okay na.
Ayan, kala ko po. Hindi pa po lumalabas. Kahit na ako po yung nagde-delete, hindi pa po lumalabas sa akin.
Meron pa? Nakaano pa sa'yo? Meron pang annotation sa'yo?
Ayun no, kakawala pa lang po.
Okay. Wala naman din sa akin. Okay. Actually, ito, ayan, we already talked about the buffering capacity. This relationship here just only shows of the buffered solution that you have to make depending on the pH na desired pH. Okay, just always remember na dapat it's within pKa plus minus 1. Otherwise, your buffer will not work as compared to other buffered solution na nasa range nito. Okay? Ito more of ano lang to, kwento-kwento. Describe how you would prepare a phosphate buffer with a neutral pH. Ito, as I mentioned, for the phosphate buffer, there are three main equilibrium reactions. The first one is the first dissociation. You have H3PO4, H2PO4 negative mixture, pwede yan buffer. You can also prepare a buffer out of H2PO4 negative and HPO4 2 negative. Okay? Tapos ito, you can make a third buffer from hydrogen phosphate and phosphate mixture. Okay? Ito, meron tong Ka1, Ka2, Ka3. And therefore, meron silang corresponding pKa1, pKa2, and pKa3. Okay? This buffer solution, this works best for a pH range na nasa pKa 1 plus minus 1. Okay? pKa 2 plus minus 2 kapag ganito. And then pKa 3 plus minus 3. Actually, I'm not sure if we have here on the, ito pala. Yan. For the phosphoric acid, look at this Ka values. Take the negative log of 7.5 times 10 raised to negative 3.
Negative log 7.5 negative 3. 2.12.
It's 2.12. 6.2 times 10 raised to negative 8.
6.2. 7.207.
And then 4.2 times 10 raised to negative 30.
4.2 negative 30. What? 13. Ako po 13 eh. 13.
13.
12.39. At 12.37 po.
38. Or 38?
Abo. 3767.
Okay. For this, if you notice, if you want to maintain the pH of the solution at around 1.12 to 3.12, the best option is to make a phosphoric acid dihydrogen phosphate buffer. Okay? If you want to maintain the pH at around 6.2 to 8.2, the best option is to make a buffer from dihydrogen phosphate and hydrogen phosphate. Okay? And if you want to maintain the pH at around 11.38 to 13.38, the best option is to prepare a buffered solution from hydrogen phosphate and phosphate mixture.
Pero ang ganda nga po, parang ano po sila, they have their specific ranges na they almost cover the entire spectrum.
Diba? Actually, yun yung ano, kaya very common na ginagamit sa phosphate buffer solution, which is PBS. We call this PBS. Okay. Common yan na ginagamit as a buffered solution, especially in medical science, sa mga laboratory, ginagamit siya. Okay? Okay. Ito lang, additional information on how buffer system reacts. Ano lang to, look at this table. So you have a buffer and it contains significant amount of HX and its conjugate base X minus. So if you add a strong acid, it will react with the X minus forming HX. Okay? If you add a strong base, it will react with the HX forming X minus and water.
Abo.
Okay? So, ganun lang gumagana. And actually, after considering the stoichiometry of the reaction, you can then actually calculate for the new pH of the solution. Okay? Is this clear?
Abo.
Okay. Just remember lang for this step, for the reaction between the buffer and the strong acid or the strong base, it is a full reaction. Kaya you have to consider stoichiometry lang. Okay? And then for the calculation of the new concentration of H+, you have to do equilibrium calculation. Clear? Is that clear? Okay to? Clear? Clear?
Narinig niyo po ako?
Okay. Hindi ko masyado narinig yung yung answer. Ito, sagutan natin yung question number 24.
Number 24, practice 19. Ba? Practice 19?
I've been, binabalik po sa Vietnam. Flashbacks.
For practice 19, this is a mixture of acetic acid and acetate ion. Ilan yon? 0.57 and 0.62 in 2 liters. Okay?
Apo.
Ano yung 0.62 na acetic acid?
Ito naman
So
po.
we have 0.62 moles of acetic acid and 0.57 moles of sodium acetate mixed together to form a 2.0 liter solution. Okay, that's for question number 19. Now, suppose we divide that solution into 2 equal portions. Okay, one portion was added with 10 ml of 0.1 molar HCl. And the other portion was added with 10 ml of 0.1 molar sodium hydroxide. Calculate the pH.
Parang ito po, parang totoo pong experiment na. Yung hiniram po yung buffer para gamitin.
Yes. So anong magiging pH ng bagong solutions? Now, originally the pH of the solution we already calculated for this. Ano yung pH niya?
Bakit po
pH 4.728.
Bakit po in-assume na volumes are additive when they literally are?
Because volumes are not additive.
What? My entire life is a lie.
Okay. Ganito, kunyari, if you have 50 ml water and you have another 50 ml water, kapag pinag-add mo yan, ilang ml yung magiging total?
Not 100 milliliters.
Not exactly 100 ml. Okay? Pero that's more of a physical chemistry concept. So, ma-cover yung idea na yun. We call that partial molar volume.
Ito po yung tawag na paradoxical.
Hindi, actually mali. For water, it's 100 ml. It should be 100 ml. Especially for water under the same condition. Okay? Pero if there are other components, kung pure water ang pinag-uusapan natin, 50 ml water plus 50 ml water should just be equal to 100 ml water. Pero kapag may ibang components, doon magkakaroon ng difference sa volume. Like if you mix 50 ml water and 50 ml ethyl alcohol. Okay? If you mix them, it will not be equal to 100 ml. Okay? Kahit walang nag-evaporate lahat nasa liquid phase lahat.
This is driving me insane.
It's a physical chemistry concept. So doon siya mako-cover actually. Okay? Pero kaya commonly very commonly you see this disclaimer here. So assume that the volumes are additive just to simplify the calculations. Okay? Kasi even if the volume changes, it will be very very minimal. Na halos hindi ma-affect yung solution.
Do not assume that the volumes are additive. State your answer to 12 significant figures.
No. Yan yung evil. Okay. So from our previous question, we have a 2-liter solution made by mixing 0.62 mole of acetic acid and 0.57 mole of sodium acetate. Now, we separate this into 2 equal portions. Initially, the pH is 4.708. We already calculated for this. Okay? Now, for each portion, you add a strong acid. The other portion, you add a strong base. Now, we need to calculate for the pH of the 2 solutions. Okay? So, let's do the HCl mixture first. Okay? So, first, we have to consider the full reaction first, the stoichiometric reaction. Okay? So, on your buffer, you have first, On your buffer, you have acetic acid and sodium acetate. If you add HCl, which species will HCl react to? On your buffered system, which species will HCl react to?
To the acetate ion.
To the acetate ion, right? So it's actually just the acetate ion plus H+. Okay? And stoic lang to, so kahit hindi molar concentration, kahit na yung actual number of moles yung gamitin natin, it's fine. Kasi full reaction ito. Okay? Strong acid reaction, full reaction. So gaano kadami ang acetate ion initially?
How much yung ano po, yung or existing na
Before you add the HCl.
pero ano na po na we assume na nag-balance out na po siya eh. So 0.57 divided by 2 plus point parang bumawas.
Hindi, ano lang muna, initial condition lang muna. Gaano kadami ang acetate ions initially?
So parang yung calculator po nagloloko eh. Bumawas bigla. Parang that's impossible. Huh? I am beyond clinically schizophrenic. What is going on? Ayun niyo po am I really hallucinating or is this real? It's real. I just realized I'm taking the half. Okay, so 0.595 po in total moles of acetate ion. Wait. At hindi pala po nagdi-dissociate na to yung HAC. I know.
Ano lang, number of moles lang. Ilan initially yung number of moles ni acetate? Yun lang yung question ko muna.
Nahanap eh. So, ano po, wait. Kailangan din, number of moles lang kahit na hindi po siya purely in acetate form?
Initial pa lang to initial concentration pa lang. Are you thinking na nag-dissociate na or parang kinonsider mo na equilibrium? No need for that. Kasi based lang on this number of moles.
Yung ano lang po, yung NaC, yung sodium acetate lang po yung
kasi ano lang naman to initial lang naman. We will still do the equilibrium calculation later. So kahit anong mangyari, i-consider pa rin natin yung equilibrium. So it's fine if you start with just the actual number of moles. So ilan for acetate?
0.285 acetate.
It's 0.285 kasi 1 liter portion lang yung pinag-uusapan natin dito, right?
Opo.
So in the 1 liter portion is just 0.285. Now, how many H plus did you add in this mixture?
0.1. 0.1 moles, 10 milliliters. So 10 divided by 1,000 times 0.1. Wait, kinakalculator ko pala. So, 1 thousandth of a mole, 1 millimole.
0.001, right?
Opo.
Moles. Tama
Opo.
Ang konti pala nung inad. Baguhin ko nga. Let's make it para mas makita natin yung property mismo ng buffer. Let's say we add not 10 ml but 50 ml. Let's say we added 50 ml. So mas madami yan
Opo, 0.005 moles of H plus.
0.1 times 0.01. Wait. So 0.005. Okay? Now, if this reacts, it will form, take note, full arrow, kasi full reaction yan. Strong acid ito. Yung inad natin. Okay?
Opo.
So it will form molecular form of acetic acid, which initially is how much?
0.62 moles.
We only have the 1 liter portion.
0.31 moles.
Now, after the reaction, the final amount of moles are equal to lahat ng H+, this will be consumed. Okay? Kasi kaya siyang ubusin ng lahat ng acetate.
If table
Right?
po. That you must refer it po to the if table as the if table.
Now, ilan na lang yung acetate tayo na matitira after the reaction?
Mako-convert kasi ma-react po yung 0.005, so matitira po is 0.280.
And how many HAC, how many molecular acetic acid will be formed?
The 0.005 will be formed, so there will be 0.315.
0.315. Okay. Now, these are the new number of moles for acetate ion and acetic acid. And we can use this to calculate pH. So pH is just equal to pKa plus log of acetate, which is 0.28, over acetic acid, which is 0.315.
Apo.
Okay? We can
Apo.
still do the ice table, pero since this is a buffer, and both the acetate ion and its conjugate acid are present in significant amounts, so we can just use the Henderson-Hasselbalch equation. So pH then for this mixture is equal to?
pKa, which is not given because I assume I must know it. 4.744 plus log 0.28 over 0.315. 4.693.
So it's 4.694 or 3.
Abo.
Tama.
Abo.
So 3 or 4, it's fine. Okay lang naman. Now, look at the initial pH of the solution. It is 4.708. After addition of 50 ml of 0.1 molar hydrochloric acid, this is a strong acid, your final pH becomes 4.694, which is not very, very far from the initial pH. Right?
It's 0.1 molar po ng acid, ng hydrochloric acid po corrosive. Kasi kung ganun po, sabihin, yung parang ano na po, yung nakasugat na po, tapos ng 50 milliliters, ano na po yun?
Not really. 0.1 molar HCl is slightly corrosive. Kapag nilagay mo siya sa tissue, for example, medyo makita mo nag-yellowish yung tissue. Nakakain yan ng konti yung tissue. Pero don't try it on your skin kasi kahit 0.1 molar, pag nilagay mo yan, masakit. Makati siya. Okay.
Yun po yung, paano niyo po alam?
Kasi na-try ko na siya.
May ano po yun dito yata po yung sinasabi nila po yung sa undergrad, yun lang po yung yung 0.1 molar.
Hindi, depende pa rin naman. We can still use concentrated HCl. Actually, yung concentrated form ng HCl is around 12 molar. Concentrated HCl is 12 molar. And if you try to open the bottle, nag-ano yan, nagpo-fume yan. Ganun siya kalala. Okay? 0.1 molar, very common naman siya na hinahandle sa lab. Pero even if it's 0.1 molar, it is still, you should still handle it with care. Kasi ano pa rin siya, it can still cause burns kung nagkaroon ng spill, for example, or kapag natalsikan ka, kunyari, kahit na 0.1 molar lang siya. Okay? Pero imagine, our solution here is just 0.31 molar 0.31 molar acetic acid and 0.285 molar sodium acetate. So 0.3, almost 0.3 molar lang din siya, which is just within the same level as yung concentration ng acid na inad mo. Right? Okay?
Apo.
Is this clear?
Apo.
Okay. Now, for the second portion, you add 50 ml of sodium hydroxide. Now, solve for the pH of the solution.
Corrupted ba po ulit niyo po yung mga files na po? Kasi parang, ba't hindi niyo po in-edit yung 50, yung 10 molar?
Ano yun? Sorry, ano yun?
Ba't hindi niyo po in-edit yung 10 molar? Corrupted na naman ba po yung files?
Hindi, okay lang. Kasi kung pag in-edit ko pa, i-close ko pa yung ano.
Close pa yung
Pero yan, at least for this problem, ano lang, in-increase ko lang. And actually, para lang mas makita mo na even if we add, most likely if we add just 10 ml, medyo mas malapit pa yung value dito sa 4.70. Tama? Pero even if I adjusted the amount of HCl that we add, 50 ml, yung change sa pH halos wala. Right? Kasi basically, both are almost just 4.7 eh. This is 4.7. This is almost just 4.7 din, di ba?
Opo.
Okay? Kahit na 50 ml, in-adjust ko to 50 ml yung inad na HCl.
50?
Now, for the second portion, solve for pH. This time, you add 50 ml of 0.1 molar sodium hydroxide.
Yun naman po, ito naman po yung kabaliktaran. It will react with the acetic acid to form the yes, it will react with acetic acid to deprotonate it and form the acetic ion.
Yes. So first write down the reaction.
Write down the if table or whatever.
Gawa-gawa ko lang yung if table. If you ask other chemists, kinonstruct mo yung if table, magugulat, if table? Hindi sila. Pero kasi usually it's just the ice table. Ice table for equilibrium reactions. For full reaction kasi, it's not really usual to write down the table. Usually, diretso stoic lang kagad yung ginagawa nila eh. Pero ako, I think it would be easier to see how the reaction went kapag kinonstruct natin yung table.
I'm adapting po yung actinium way of writing acetic acid.
Sorry, yung meron pala tayong easy sa periodic table.
Unfortunately, may nadamay po na.
What's that? Hydroactinic acid? No. That's just acetic acid.
If table. Whatever this is. Point 31.
Question. Question. If you use that, which PKB are you going to use?
The PKB of I have no idea. So, ginamit po natin yung PKA po dito. Ginamit po natin yung Ginamit po natin yung PKA ng acetic acid, not hydrochloric acid. So, I'm assuming po dito, we're going to use the KB of acetate ion and not the NaOH.
Actually, kahit ano pwede nating gamitin. Okay? Pero ano yung mas madaling gamitin?
NaOH.
No, yung part na to actually, sorry, ano ko lang i-explain ko lang ng mas maigi. This part here, this is the full reaction. Okay? Itong part na to, this is the equilibrium reaction. Although, approximation yung ginagawa natin dito, hindi na natin ginawa yung ice table. Remember, Henderson-Hasselbalch equation is based on equilibrium reaction.
Opo.
Okay? Now, yung H plus or OH minus, yung effect nila doon sa mixture, natatapos na sa part na to. Okay? After you calculated for the final amount of acetate ion and acetic acid, hanggang dun lang yung effect nung added H plus or added HCl.
So,
Okay?
mawala na po sila.
This final state here, ito yung magiging initial state nung equilibrium reaction, nung equilibrium condition.
Opo.
Did you get it?
Opo.
Okay. So tandaan mo, yung Henderson-Hasselbalch equation natin is the equilibrium calculation. Okay? Now, whether you use the Henderson-Hasselbalch equation in the form of pH or POH, okay lang. Pero still, ang system natin ay acetic acid acetate mixture. And very commonly, what we give or what is given for this type of buffer is a Ka or pKa.
So, I will find, I forgot na naman po the theorem na Kw is equal to Ka times Kb when they are,
Yes.
when they are conjugates.
Okay. So actually for this case, I think it would be impractical to solve for the POH using this equation. Kasi you can just easily write down or use this equation here. Kasi pKa of acetic acid is readily available. Right? And besides, this equation here already gives us the pH. Is that clear? Clear ba yun?
Opo. Bakit po tawag po P, yung P function? Is there
Bakit ano?
is there an etymology behind why they use the letter P to denote negative logarithm?
Wow. Hindi ko yung naisip actually. I'm not really sure about the answer then. Hindi ako sure kung bakit siya tinawag na P function and why they add P for terms or expressions na kinukuha na natin ng negative logarithm. I'm not really sure then.
Abo. Siguro po may mathematical function na parang gano'n po, something na in-adapt lang.
Maybe. And why P of all the letters? Right?
Apo. For some reason po, I dislike the rounding down system, but I constantly use it for some reason.
Okay, final answer?
Probably po.
Probably. Anong probability?
Kasi
Just,
for my experience po, any OH, kinakain po natin, di ba? Nilalagay po sa rice cake. Pero yung ACL, it's too dangerous to even put on food. So, I'm assuming,
no.
di pala, corrosiveness pala yun eh. Yung ano pala, yung strength ng, I'm assuming the strength of HCl is stronger than the strength of any OH.
Actually, for this case, if you'll notice, yung difference between this pH and this one ay equal lang din sa difference ng pH nito at ng pH na to. Tama ba?
Literally, ito po yung I just realized. Ano pa rin, it still makes sense, it still makes a little sense po, pero it's a little weird po na nag-ano po, the pH became more basic than the pH became more acidic when we put an equal number, when we put a sort of equal number po ng HCl.
Yes, pero ano naman, very common pa rin naman yun. I mean, there's still really that tendency na mag-increase or mag-decrease. Pero if you'll notice, when you add this HCl, nag-decrease, but very slightly yung pH. When you add sodium hydroxide, the pH also increased, but very slightly lang din. That's how buffers work. Okay? And for this is correct. Okay? Now, actually, if you proceed with your calculation kanina, POH, this is equal to PKB plus log of,
Sinunod na po A.
sorry, PKB. Kasi POH. PKB, so this should be acid over base. If you use this, ano yung magiging POH value?
I still have to calculate for KB. So anyway, I'm already in that trouble. So 1 times -14 equals 1.8 times -5 times x. Interesting. 5.55555. Anyway, negative log whatever it is plus log acid is 0.305 over 0.29. POH po is 9.277. 14 minus.
So from this POH, pH is equal to
4.723.
Diba? Pareho lang. Right?
Opo.
Kasi remember, it's a buffered mixture. So both the weak acid and its conjugate base are present in significant amount. So kahit aling side mo siya tignan, pareho pa rin dapat yung magiging final answer. Okay? But just make sure lang na tama yung mga constants na ginagamit. If you use this equation here, you need to use pKa of the acid. Sino yung acid form? Si acetic acid. If you use this equation, you need to use the pKb of the base. Sino yung base form? Acetate ion. Right?
I'm wondering that po. Are there any anions that are meron na pala po yung ano po. Yung bisulfide po, 'di ba? Acidic. I thought po wala pong anion na acidic. Are are there metal ions po that are negative?
Metal ions that are negative.
Opo.
In water, I don't think very common makaka-experience tayo nung ganun. Most of the metals are positively charged in ions, in their ionic forms. Pero in some other forms, kung hindi aqueous mixture, for complexes, for example, there are also some metals na nag-exhibit ng negative charge. Pero that's a different case. Okay, and
Opo.
most likely, it is not in the form of an aqueous solution. Pwedeng gas phase na merong na nakabond siya with other ligands, what we call ligands. Medyo mako-cover yan pagdating sa coordination chemistry na part.
Opo.
Okay, pero it's very uncommon for metals to be or to have a negative charge in aqueous solution. Most likely, they are always in the positive charge form. Okay. Now, I'll also just want to emphasize na for this buffered solution, take note na even if we add this strong acid here, HCl, or strong base here, sodium hydroxide, we didn't really observe any significant change in the pH. Actually, if you solve for pH of the solution, a 0.1 molar HCl has a pH of
0.1
pH ng
molar.
0.1 molar? What is the pH of a 0.1 molar HCl?
Opo. I forgot the... Hindi. Ano pala? Yung 1 molar is exactly 0 halos.
0.1. Ito lang. This solution here. What is the pH of this solution?
0.1, negative log 0.1. 1. Bro, I realized it was that easy pala.
Right. HCl lang yan. So 1 yung initial concentration, that's also the H plus concentration. For a 0.1 molar sodium hydroxide, what is the pH?
Dissociation din siya, so 13.
13. Right? So imagine you added a solution, 50 ml of it. Okay? A solution with pH 1 and another solution with pH 13. Pero you didn't really observe any significant change in the pH of the solutions. Is that clear?
So basically po, you're mixing a solution, you're mixing a 50 ml solution that is 10 times more acidic than lemon juice. Then for
In
the
terms
other
of
one,
hydrogen concentration, right?
isa naman po, unfortunately, it's literally 1,000 times more powerful than bleach.
Okay. Now, na ano mo yung tawag dito, yung strength or yung properties ng buffer, right? Ganun sila. Okay? Do you have questions?
Very po yung concept of the buffer kasi inisip na po para may chain reaction.
May chain?
May chain reaction po. Pag may dinagdag po ko na to, it will turn into the ion, but then there will be an effect.
Actually, ganun siya. And common examples of biological buffers is yung blood mismo natin. Our blood is actually an example of a buffered solution. Okay? Kasi we have to maintain the pH of our blood at around neutral pH. It can't go very acidic or very basic. Otherwise, it will cause some problems with how our body functions. Okay? Hindi yun pwede. So yung blood mismo natin, meron siyang natural buffer system. Okay?
Kung ginawa niyo po, uminom po kayo ng 500 uminom po kayo ng 1 liter of 12 molar hydrochloric acid para
No.
mag-ibang po.
Ang ano naman diyan, hindi na buffering capacity yung sinusubok mo niyan. Ang sinusubok mo na is yung kung gaano katibay yung esophagus mo for corrosion. Kasi syempre pag ininom mo bago ma-reach yung blood, ano muna, tawag dito, tatamaan muna yung ibang parts ng
Tingnan po
katawan,
yan.
right?
Ano na, non-existent na po yung esophagus niyo po at that point.
Don't do that, okay? And actually yung yung buffer system sa blood natin is mainly composed of the carbonic acid carbonate buffer system.
Opo.
Carbonic acid
This carbonic acid actually exists in its pure form. This carbonic acid po actually exists in its pure form na we can look at it or something.
Hindi, ionized form yan. Ionized form yan.
Okay.
Kasi aside from this, marami pang components ang blood. There are protein contents, there are ion contents, sodium ions, potassium ions. Pero yung mismong nagko-control ng pH, these are the bicarbonate and carbonate mixture. Okay? Bicarbonate-carbonate mixture. Sorry, I think it's carbonic acid. Carbonic acid bicarbonate mixture.
Ayun. Opo.
This one. Ito, mas mataas yung pH nito. Yung around 7 pH, ito yon. Tingnan nga natin yung Ka value. Polyprotic. Ito, carbonic. Get get pKa1.
pKa1, negative log. .3665.
6.366 or 367.
POV,
Okay.
wala na
Plus 1,
wala na
7.30 something. So it maintains the pH at around 6 to 7. Okay.
Bakit po siya on the acidic side? Does this mean our blood is supposed to be on the acidic side when it's actually more on the basic side?
Actually, I think it's more on the acidic side. Pero yung pagka-acidic niya naman is still very close to neutral. Hindi, lang to, hindi ito yung actual pH ng blood. Yung actual pH ng blood is somewhere between 6 and 7. Okay? Pero ito yung buffering capacity ni carbonic acid. So that's why the carbonic acid bicarbonate system works for our blood. Kasi it's very close to the neutral pH. And di ba ang gusto ng blood ma-maintain yung neutral pH? Okay? Questions? Do you have questions?
Wala na po.
Sure. Is this clear?
Opo.
Okay. Kung clear na, then that ends our discussion for today. By next meeting, actually, we will do solubility equilibrium. Pero mabilis lang to.
When there's another topic of equilibrium that exceeds literal equilibrium.
Ano na to? Kumbaga, so far ang na-cover natin sa equilibrium, we consider general equilibrium, mostly gas phase reactions and heterogeneous equilibrium tinignan natin. At this point, we are looking at aqueous equilibrium. The first one is on acids and bases. Tapos ito ngayon, yung next topic natin is on solubility equilibrium. Okay? So, ayun. Kung okay na and you don't have any more questions, then I'll see you on our next meeting. Okay?
Okay po.
Thank you. Thank you.
Thank you po.
Okay. Si Sir J, wala, no?
Wala po siya. Bumalik po siya sa tirahan.
Okay. Sige. Okay na, okay na?
Okay po.
Sige, okay na. Sige. Bye-bye.
Bye-bye po. Thank you po.
Bye-bye. Thank you, Joshua.
Opo.
Sige, I'll see you next meeting.
Opo.